Cloud security is not just about the tools, the encryption, backups, access control, and monitoring. Think about it. What good is a high-tech padlock if you just leave the key right in the door? Those tools absolutely need rules behind them. And that is exactly what governance is all about. It's the framework that ensures your cloud systems are used safely, consistently, and responsibly across the board. Now, this is especially critical for small and medium-sized enterprises. Why? Because cloud services are usually adopted at breakneck speed. You might have a business rolling out cloud email, online storage, accounting software, CRM platforms, and payment tools, literally all at the exact same time. Without common rules, each of those systems is going to be managed differently by different teams, and that creates a very real security nightmare. Governance steps in to bring much-needed consistency. It helps you definitively answer exactly what data you have, who can access it, how it's being protected, and crucially, what happens if something goes wrong. Let's dive right into data encryption. At its core, encryption protects your information by making it completely unreadable to anyone who doesn't hold the correct key. So even if an unauthorized person somehow gains access to a file, a database, or a backup, they won't be able to understand or extract any of the information inside it. It essentially turns your most sensitive data into useless gibberish to anyone looking from the outside. When we're talking about cloud environments, this protection really needs to be applied across two critical states. First up, we have data at rest. This is the data just sitting there, stored in your databases, storage buckets, backups, or virtual disks. And then we have data in transit. This is the data actively moving around between users, applications, APIs, and various cloud services. This moving data is typically protected through secure connections like TLS, which is the standard technology that keeps our internet connections secure and private. Both of these states absolutely require specific, robust protection methods. You can't just protect one and ignore the other. You'll also see many cloud providers utilizing what's known as envelope encryption. This is a brilliant example of a layered defense. Here's how it works. The data itself is encrypted with one key, and then that key is protected by another master key. That master key is usually managed through a dedicated key management service. For your organization, the takeaway here is quite simple. Sensitive data should be encrypted by default, period, both when it's securely stored and when it's in motion between systems.
But of course, encryption is only effective if your digital keys are actually managed properly. Key management is the specific way an organization controls the keys that protects its cloud data. Think about it for a second. If someone gains access to the key, they can easily unlock the data, right? It defeats the whole purpose. So those keys have to be rigorously shielded from any unauthorized access, honestly, just as fiercely as the data itself.
This is exactly where cloud key management services, tools like AWS KMS, Azure Key Vault, or Google Cloud KMS, become absolutely indispensable. These tools allow you to safely control the entire key lifecycle. We're talking from creation to secure storage to regular rotation and finally controlled deletion. Relying on these dedicated services is infinitely safer than storing keys in risky locations like emails, shared folders, or, worst of all, application code. Now, a strong, simple key management policy has to establish clear rules. First off, access must always follow the principle of least privilege. That means only authorized users and systems should ever have access, no exceptions. Also, all key activity must be logged. And then there are the strictly forbidden practices. Keys should never, ever be sent by email or chat. They shouldn't be saved in screenshots, hard-coded into applications, or uploaded to code repositories. The goal here isn't just to create extra paperwork for you. The goal is to make sure everyone in the organization is following the exact same safe rules. Moving on, governance is also fundamentally about deciding how long your data should actually be kept. So many organizations fall into the trap of being digital hoarders, just keeping too much data for far too long. We see old records, exported spreadsheets, outdated backups, and former employee files just sitting in cloud systems long after they're actually needed. This needlessly increases your organization's risk profile, and it doesn't add any business value whatsoever. To counter this hoarding habit, a strict data retention policy is required. This policy needs to explicitly define how long different types of data should be stored, where they're allowed to reside, who is actually responsible for them, and exactly when they should be archived or securely deleted. Now, obviously, some records have to be kept for legal reasons, but temporary exports or day-to-day operational data, that stuff needs to be deleted much, much sooner. And notice the direct link here between data retention and encryption. It's a bit like a puzzle fitting together. If encrypted data is mandated to be kept for 5 years, well, the keys protecting that data must also be managed securely for exactly 5 years. The underlying principle here is incredibly simple. Do not keep everything forever. Keep what is needed, protect it properly, and delete it when there's no longer a valid business or legal reason to hold on to it. So let's shift our focus a bit to see how all of this builds into operational resilience. Because let's face it, even with ironclad security, mistakes happen. Files might get deleted accidentally, ransomware could hit your business data, or a major cloud service outage could just take things offline. Governance demands a robust strategy for exactly these scenarios. You have to plan for the disruption long before it actually strikes. A methodical backup strategy is going to cover 4 essential criteria. It dictates exactly what needs to be backed up, how often those backups are created, where they're securely stored, and who is ultimately responsible for managing them. And this is vital. The backups themselves must be treated as highly sensitive assets. They need to be encrypted, access restricted, and safeguarded against both accidental and malicious deletion. But having backups is really only step 1. The organization also has to know how to quickly restore them. A proper disaster recovery plan relies heavily on 2 fundamental metrics. First is RTO, or Recovery Time Objective, which defines exactly how quickly a system has to be restored to get operations back up and running. Second is RPO, or Recovery Point Objective, which defines the acceptable amount of data loss during an incident. These 2 metrics shape your entire continuity planning and really set the standard for your organization's survival. Now, business continuity planning explains how the organization actually keeps operating while that recovery is taking place. But I want to share an authoritative principle that you absolutely must remember. A backup that has never been tested is only a hope. A tested recovery plan is a real control. It is an absolute necessity to regularly test these recovery plans. You have to know for sure that they're going to work when you actually need them. Furthermore, cloud governance doesn't just exist in a vacuum. It is explicitly shaped by regulations and industry frameworks. The specific obligations that your organization must follow depend entirely on the type of data you handle, the sector you operate in, and the geographical locations of your customers. Let's walk through a few of the specific frameworks you might encounter. Over in Europe, GDPR requires appropriate protection, like encryption and secure deletion, for personal data. Then you have NIS2, which focuses on broader cybersecurity risk management and incident reporting. If you're operating in the finance sector, DORA targets your operational resilience. Over in the United States, HIPAA mandates strict health data protection. And on a global scale, PCI DSS governs how anyone, anywhere, processes and stores payment card data. So, as we wrap up this module, remember that cloud security governance ultimately empowers an organization to confidently answer 5 essential questions. Number 1, what data do we have? 2, how is it protected? 3, who can access it? 4, how long do we keep it? And 5, can we recover it? By defining these rules behind the tools, your cloud environment transforms from a potential liability into a highly structured, resilient asset. So I'm going to leave you with this thought to take back to your own teams tomorrow. If your primary cloud environment went down right this very second, how many of those 5 questions could your organization actually answer?